To create an app to remotely control your Nano Mouse, open your web browser and navigate to appinventor.mit.edu. Once there, click on Invent. You'll need a Google account to log in. Once you're in, go ahead and create a new project. Go to My Projects and then New. And we'll go ahead and create something that says Nano Mouse Remote. Mouse Remote. It can't have any spaces. I'll give that a minute. It should say Nano Mouse Remote up in the left corner here. And we're going to need make a few different changes to the way the screen's set up here. The first thing we're going to do is we're going to make the orientation landscape. We're going to not let it be scrollable. And then we're going to change the title of the screen to Nano Mouse Remote. And I'm going to upload a little icon that I found that I sort of found and then adjusted on the internet here. You can go to Google and find a little icon that makes sense to you. I just picked a picture that's the same as the Bluetooth module that makes all of this possible. Okay. So now my app will have that icon when I go to find it on my phone or tablet. Alright, the first thing we want to do as far as creating the user interface is drag a button on here. I like to make my buttons a little bit larger, and I'm going to make the text say connection, and I'm going to rename the actual button connection. Okay, and it's going to be by default red, and I'm going to use the color to signify whether or not we're connected. The next step is to grab a list picker. The list picker is actually not going to be visible, so the only thing I'm going to do here is change the name of it. And the reason we're using a list picker in conjunction with a button is because it gives us a little more flexibility over how our app works. So it says visible showing, I'm going to say hidden. So now I can see that I have a list picker over here, but I don't see it on the screen. Let's see. The next thing I want to do is grab some screen arrangement tools. I'm going to grab a vertical arrangement and put it right here. And I'm going to set its width to fill parent, its height to fill parent. Actually, I'm going to leave that to automatic for right now because I want to put in a horizontal arrangement below it. And now, if I make this one fill parent, it's not going to make many changes yet, but it will make it'll adjust things shortly here. I'm going to make the width on the horizontal one fill parent, and then the height will be automatic. So the next step is to grab some labels. I'm going to grab a label, put it right here, and call it label label power. And then for the text that shows, I'm just going to put power, with a little colon and a space after it. The next label is going to be steering. The reason I'm doing this is just so that I get feedback from my app as to what it thinks what it's reading and what it thinks it's sending to the what it is sending to the mouse. Sometimes you do the math wrong. This is a good way to catch that. So rename this label steering. The next step is to put a label here. And now, because I've have the height of this one set to fill parent and this one set to automatic, we see that it scrunches down. The next step here is to rename this label. We'll say label left motor. I'm going to change its text to left motor. And then I'd like a right motor on the right hand corner here. The easiest way to do that is to get one more screen arrangement. It doesn't really matter if it's vertical or horizontal. Put it right here. It's going to make everything big, but I can fix that by saying height. I'm just going to make it 5 pixels. So it's really short. And then I'm going to make the width. Well, before I change the width, I'm going to put in another label. I'm going to make that label right motor. And then I'm going to make this width fill parent. Okay, that pretty much completes the GUI part of our app. Now we have to include some components that are non-visual components. And so I'm going to click on Other Stuff, and I see a Bluetooth client. We're going to need one of those, so I add it by clicking on it and dragging it to the middle. I'm going to rename it because I can't stand having the one on the end. I need an accelerometer, so that's going to be under Sensors. And I need a clock. That's in the basic. And last but not least, I will need a notifier. Let's see, I believe that's under Other Stuff. Yep. I don't really have to change any settings on here except for the clock, which instead of having an interval of 1,000, I'm going to make it 50. So this clock is going to go off every 50 milliseconds instead of every 1,000 milliseconds, which would be once a second. That'll make our robot much more reactive. That's the end of the design stage of making this app. The next step is to program the back end. So I'm going to open the blocks editor. Depending on your computer, this may take a while. You also have to install this software in order to get it to work. So if you have trouble with it, look at the documentation for installing App Inventor on your computer. You can find that documentation under Learn. If I just click on Learn, you will see a large number of tutorials, and in the tutorials you'll see setup instructions. So just follow those instructions and you should be able to have it up and running, no problem. So here is the blocks editor. This is where I create the logic for my program. The first thing I'm going to do is go to My Blocks and get the list picker. I'm going to say list picker connection, and I need to figure out what's going to happen before I pick something. And what I can do is set the list picker elements. Let's see here. List picker elements to the Bluetooth client addresses and names. However, there's a problem with this. There's actually two problems. The first one is I might not be paired with anything. Nowadays this is probably a much less common problem, but we're still going to go ahead and control for it just in the event that that does happen. So what we'll do is create an if-else statement. Put this in the else side. And then we're going to test to see if the length of list is equal to, so I'm going to see, length of list of the Bluetooth addresses and client addresses and names, if that's equal to 0. If it is equal to 0, then I need to give myself a little message, and so I'm going to use the notifier. And the notifier is going to say show alert, and the alert's going to be a real simple message that says, let's see here, you must pair your Android device with a Bluetooth module prior to using this app. Okay, so that's the first error that can occur. The second problem might be you don't have your Bluetooth radio turned on. I leave mine off most of the time. And so what we will do now is put this in the top side, and then test to see if the Bluetooth radio is on. So Bluetooth client, and there should be an enabled. If the Bluetooth client is enabled, then we want it to go through this step. If it's not, we need to give ourselves another little message, and that message is just going to say you must enable your Bluetooth radio before you can connect. There we go. That takes care of the before picking logic. Now we need to decide what we're going to do after we pick something. That part's fairly easy. We're going to have to use an if statement. This is a little bit counterintuitive here, but that's how it works. Just say if Bluetooth client connect is equal to the list picker connection dot selection. If that's true, if we've connected, then I want to change the background color of my button. So I'm going to switch it to green. This is why we're using a button in conjunction with a list picker, to give us the control over the background color so that we get visual feedback about whether we're connected or not. The next step is to put the logic for the button. So it's going to be a toggle button, so we're going to have to use a if-else statement here, and it's going to be based on whether or not the Bluetooth client is connected. So client, here we go. If we are connected, then I want to say disconnect, because it's a toggle button. If we are, and then if that happens, we also want to change the background color of the button to red to signify to the user that we are disconnected. The next step is, however, if it's already disconnected, then what we want to do is connect. We want to do that by triggering the list picker connection event. So I'm going to say list picker connection open. So this button, if we're not connected, it engages the list picker, which goes through its logic. If we are connected, it just disconnects. That's the end of the logic there. Now we're going to have to create 4 variables. So I'm going to go to built-in definition. I'm going to drag a variable. This one's going to be called power, And the next one's going to be steering. The next one is going to be, say, left motor. And the last one will be right motor. Okay, so the very first thing we need to do is define what's going to happen every time the clock goes off. And what we're going to do is read accelerometer values and store those to the power and steering values. So now that I've defined these variables, I can actually write to them and read from them. I'm going to write to them an accelerometer value. Let's see here. Now, there are three axes that you can choose from. For my cell phone, the z-axis is what I want for power, and the y-axis is what I want for steering. However, the tablet, I orient it the same way, just doesn't work this way. It has different axes. What you need to do is play around with these axes when you're debugging your program to make sure you have the right one selected. This may not be exactly what you need. The next thing I'm going to do is multiply these values by a number to make them a lot larger, because right now they only vary between -10 and +10, and I want them to vary between -100 and +100. So there we go. The last thing I want to do before I store them into the math, those variables, the power and steering variables, is round them. I don't need the resolution that these have, which is up to several decimal places. So there we go. Alright, the next step is to set the labels. So I'm going to go back to my blocks, label power, and I'm going to set its text, and then label steering. I'm going to set its text. And I'm going to do a nice little trick here. If I go to text, I have a join command. And what I can do is have it so that it prints really nice. I can have it print the word power with a colon and a space followed by the actual number. Okay, and I'll do the same thing for steering. Okay, the next step is to translate the power in the steering into left and right motor power levels. So I'm going to grab the left motor variable and the right motor variable. And this is just a trick. If you actually work it out and go through exactly what's happening, it makes sense. But as far as using it, it's just a matter of power plus steering is a good number for the left motor, and power minus steering is a good number for the right motor. There we go. These will give you values that control your robot in an intuitive way. If you are curious, I suggest that you work it out. If I'm working with you, please feel free to ask me and I'll be happy to explain it in greater detail. The next step is to coerce these values into being reasonable. Occasionally they're going to be a little too big or too small, and so we just need to have a series of if statements that say something to the effect of, if the left motor power is less than negative 100, then I want to set the left motor equal to negative 100. I don't want it to be anything below 100. And I have to have the same thing for the right motor. And then I can actually copy this and just change a few things. Now I want to say if the left motor is greater than positive 100, then the max I want it to be is 100. And if the right motor, same thing for the right motor. The next step is to create a deadband. Right now, if I program my robot, it would be very hard to keep it still. So I'm going to go ahead and copy this value, this block of code again, modify it just slightly again. I'm going to say if the absolute value of the left motor be nice if this was in alphabetical order. If the absolute value of the left motor is less than positive 10, so if the left motor is negative 5, the absolute value of that is 5. If that's less than 10, I have a problem. Anything ranging between negative 10 and positive 10 will trigger this to be true, in which case I want to feed the power level a level of 0. So when I'm close to 0, I want to feed my motors, the instructions to turn off. It's hard to get them right on the money, so this kind of helps it out, makes it a little bit easier. We'll do the exact same thing for the right motors. For the right motor, it's less than 10, and I need to get the absolute value. Feed it a power level of 0. Okay. Now some more debugging here. The next thing I want to do is actually print these to the screen so that if I made a mistake, I can actually see that. Okay. So just put in the variables for each one. Nope, not quite. I want to go ahead and do the join trick again to make it look nice and pretty. So now I'm printing it to the screen. The next thing is to actually send it to the robot. I'm going to use an if statement here to only send it when I'm connected, because if I send it all the time, I'm actually going to get a bunch of messages that say, not connected, and it's going to lock up my phone, which is never nice. So Bluetooth client is connected right here. If I'm connected, I want to send a very simple message. Bluetooth client. I want to send bytes. And the bytes I want to send, I have to make a list. I have 2 of them. I want to send the left motor level in my definitions. Left motor and right motor. So this is going to send to our NXT, or sorry, send to our NanoMouse numbers that range between -100 and +100. The first one is going to be, the left motor will be the first byte, and the right motor will be the second byte. That's it for the programming side, or the Android app programming side. Now it's time to go to the Arduino, to go program it on the Arduino side.